Sharding for the masses. Who knows about sharding? Who is using sharding? Okay.
Peter Zaitsev says not to use it, so no.
Yeah, I know. I know Peter Zaitsev. I have an Italian accent, not a Russian accent, so that's the difference. Sharding for the masses is something that really exists. If you know about sharding, you will see that this will make you think about what you can do. Now, first, my name, if you may see it here if you're close enough, is Giuseppe Maxia. I am MySQL community team lead, also known as the data charmer. I have a self-published t-shirt, and I'm known in the MySQL community for my hacks, and for my hacking tendencies. So let's go to the real business. What is sharding? Sharding is a strange word. It means breaking something. If you're thinking about a database, usually you think about splitting or dividing, sharing. Instead you say sharding. Sharding is a word that is used for something that you break, like a piece of glass, a piece of ceramic. It's strange when you hear sharding, you think about something that is chopped to pieces with an axe. It's a crude word, and you wonder why. There is a reason why we say sharding and not something else, because sharding is really breaking a database to pieces, and sometimes you have problems taking track of what you have done. So first of all, why do we use sharding? We have 5 good reasons for sharding. Yes, that many. So scaling is the problem with sharding. Why do you use sharding? Just because your database has some problems and doesn't grow the way you want it, and then you start sharding. So what is the problem with sharding? The problem with scaling. You start with one server, everybody does that. Everything is fine. Then one sorry day you become successful, and instead of having 10 customers, you have 1 million. And you are happy because you have a lot of money in the bank, but your database doesn't work anymore and you may fail. So you have too much data and too much traffic. What to do? The usual solution for MySQL users is replication. This is called the Yahoo way, just because it was Yahoo the first that made it known that was used MySQL replication for scaling. And after a while also Google admitted that they are using MySQL scaling with replication. So this works. It's a scalable solution. How does replication work? It's very simple. You have one master where you write your changes. You have several slaves. Your application must be smart enough to recognize that when you write something, you send to the master. When you read something, you read from one of the slaves. So using a load balancer with the slaves, you scale web applications. So the difference between what you do and what Google does is that instead of having 3 slaves here, you have 3,000. but the concept is exactly the same. And it scales very well. If you have a web application where you write not much and you have millions of users that want to read what you have, you can just keep adding slaves and everything works fine. It scales mostly indefinitely. You can also use hierarchical master slave. So every slave can become master of more slaves. This is what Google does. It works. Almost always. So when does it fail? When your master doesn't have enough resources to cope with what you do. If you have too much data that doesn't fit in the master, then you are in trouble. You can scale as many slaves as you want, but the master is only one. So this is what you have, the problem that you have with the application.
What do you mean, why can't I have many masters? Why can't I have many? What do you mean there's only one master? Why can't I have many masters?
You can have many masters, but it's not built in MySQL. You have to do some tricks. You can do circular replication, you can do a master using Linux HA or DRDD. There are many composite solutions that you can duplicate the master. At least you can have two masters. But it doesn't solve the problem of too much data. Because if you have too much data, even if you have two masters, you're not solving this particular problem. You can split the number of connections eventually, but not the problem of too much data. So if your data doesn't fit in one master, you are back to the drawing board and you have to decide what to do. So your master must grow somehow, and if it doesn't fit in one post, you have to be creative. So what do big companies like Facebook do? Facebook is using MySQL, but of course it's not using this, because you cannot fit 200 million users in one MySQL server. So people like Facebook use sharding. I call it homemade sharding here because it depends on specific solution that change for every application. So Facebook has its own solution, Twitter has its own solution, another company that does a similar job, they have their own solution. We have seen a presentation by Julian, what is his surname of Julian? Perrin, who was a social network company in Hungary, and they developed a sort of general purpose PHP application that does sharding. But in general, it works like this. You have application logic that tells you where to write and where to read information from. For instance, you can say users from number 1 to number 1000 go to host number 1, and here is where you get it. The application logic tells you that from 1 to 1000 is host 1, or it simply tells you a formula how to find the host given one specific piece of information. You can use alphabetic order or whatever you want. It means that everything that you want to do with your database is not self-contained in the data, but it depends on the application. It works fine. It works well, it's fast, but it has some problems. How can you break sharding? Simply, you remove the application logic For instance, you want to use different program to deal with that, and all of a sudden your data collapses. The data is still there, but without the application to give you the meaning, you don't know what to do. So this is the big problem that you have with homemade sharding. Or you can break it in a different way. You may have chosen the wrong parameters for your sharding, and if you do that, you find yourself with an application that you cannot deal with anymore. It becomes too complicated, and you are in trouble because your application doesn't scale. You cannot keep track of everything that you have done to control the server that you are adding to your schema. Do you follow me so far? So you know, homemade sharding works, and you have proof of that if you see applications like Facebook that really are big on sharding. So given the difficulties with homemade sharding, there are people looking for magic solution. You want to have something transparent. Mostly it has been done using proxies. Proxy is something that is an application that is between the client and the server. And inside this application you write the business logic of your sharding. Using this you can do something that looks like a transparent solution. There is MySQL proxy that can be programmed using a scripting language and allows you to do sharding. This H-scale solution that is mentioned here is built on top of MySQL proxy with a Lua application. And Spook proxy is a Spock proxy is a fork of MySQL proxy without Lua scripting, that is being specialized for sharding. So both of them work, but they are problem. They don't scale. It's a single point of failure. Everything has to pass through one proxy. You can also replicate the proxy and attach a proxy to each web server. It sort of works, but again, it doesn't scale as well as it should. So far, this is the problem. Everybody with me? Is everything clear? So this is what we are dealing with. Now, spider. This is not a spider, but it's cute. Spider is something new. It's an application. Actually, it's not an application. It's a component of MySQL server. It's a MySQL storage engine. So it's a plugin that you can compile and put inside the server. It is developed by Kento Kushiba. He's a Japanese guy, very bright. I saw a presentation he made at the users conference. He was wearing Spider-Man outfit. Unfortunately, the Spider-Man outfit was too tight for me, so I couldn't wear it. And he did this engine on top of the partitions engine. Now, stop for a minute. Who knows what partitions are? Okay, so I don't have. Do I have to give you a quick 10 minutes presentation of partitions, or shall I assume that you know?
Can you just go to between a partition and a shard?
Say again?
Difference between a partition and a shard. Are they different? Or are they different?
Partitioning. Vertical versus horizontal.
Or did you just mean partitioning like partitions in MySQL 5.1 partitions?
Yes, partitions in MySQL 5.1 partitions.
Okay.
So this is MySQL 5.1 partitions. For the ones who don't know partitions, let me tell you in short what is it. It's a way of splitting, logically splitting a table. You have a full table, but you can define how it splits. For instance, you can say IDs from 1 to 1000 go to partition 1, IDs from 1001 to 2000 to partition 2, and so on. The table behaves like any MySQL table, so you don't have to remember where to put things. You just push records inside the table, and when you search for the records, the partition engine will make sure that you are only reading the partition that is involved in that case. So if you are looking for record 4001, instead of looking to all the table, the partition engine will restrict to that partition that contains 4001. If you have a table with 100 million records, it doesn't look all 100 million records. It doesn't read the index for 100 million records. It reads the index and the table only for that small piece of data. But for you, for the user, it's transparent. You see a table. It looks like a table. It behaves like a table. You just know that using partitions, it's much faster to retrieve data. So this is partitions in a nutshell. I can talk about partition for 6 hours if you want, because I made a tutorial for the users conference and I wrote a bunch of articles, but I spare you for now. So I assume that now you are experts on partitions, and what you need to know is that the Spider engine is built on top of partitions. So it associates each partition to a remote server. So it looks to you like a table, normal table, but in reality is doing what your application was doing in the homemade sharding. It knows that your data belongs to a specific remote server, and it connects to the remote server, gives you back the data, and for you it's like the data was inside the server. So let's see an example, the conceptual model of Spider. You have a table and you create partitions. So the table employees. Partition 1, you have year 1997, and you tell the Spider engine that it goes to host 2. Partition 2, year 1998, and you tell the Spider engine that it belongs to host 3, and so on. In reality, in this table, you don't have anything. There is no data here. It's just a placeholder. It's just a description. It's for all purposes an application. But it looks like a table and it behaves like a table. So whenever you look for data here, you will just issue a query and you get the data. How? So let's continue the conceptual description. You send a query from a client to this table. So the table is in host 1. It receives this query that looks for employee with the date in 1998. what does it do? It looks at this internal table, identifies that this belongs to host 3. So it sends the query to host 3. Inside host 3, they receive the query that is sort of the same thing that you are sending from the client, with some additional or different parameters. It gets all the data that match your request, and eventually it sends it back to the server, and finally this server gives you, the client, the answer. Everything that I've shown here is transparent for you. You don't see anything of the sort. You just ask this question, the question to this server, and this server will return the answer to you. In reality, you have a batch of servers that are working in the background for you. Is that clear? So, I told you that this doesn't have any data. A corollary of this information is that you can have several spiders in different hosts pointing to the same data. Think about that. This is something that has not been used very much, actually has not been used at all. It's something that I found out in my tests. So you have 2 different hosts with the same definition of spider, and you can ask the same question to this host and get the same answer. Or you can modify the data from 2 different places, and you should have the same results.
So the spider basically speak the normal MySQL client server?
Yes.
But in terms of loading those data servers, I mean, doesn't matter how many spiders you have, all the load will finally end up in your data servers, in the same data server.
If the definition is the same,
Yeah.
yes, you can do something even more subtle. You can have a different definition of the windows here, and end up in different servers. I'm not sure if this is a smart idea though, because you may end up spoiling the partitions. Because, you know, the remote servers don't know anything about Spider. They are normal MySQL servers. You can have MySQL 3.23 there. As long as you send queries that is understood by that server, it's fine. So if you're not sending sub-queries, and usually the Spider engine doesn't know anything about sub-queries, even on MySQL 3.23 works. It's like using a federated engine. So the only thing is that this architecture is speaking the MySQL client server protocol. So in remote, you have MySQL servers, and they behave like and this is a client for them. Every server sees from here that there is a connection from a client, and that's it. I'm going to give you more information on how to set this connector, so you will see what goes on.
Is there any impact on speed?
Yes, it is. There is an impact on speed.
Because federated tables are quite slow, let's say.
Yeah, but consider that if you have all the information in one table here, if you put 4 million records in one table, or if you split 4 million records in 6 servers, the query through the Spider, even with the connection, is faster. This is the whole concept. Yes?
Where are joins executed? If you join the table with another.
The spider is transparent, so you have to be careful when you join this kind of tables. Usually you should not, but it does. If you want to join it, it's going to be a full table scan or a full partition scan. So if you, it's a common problem with partitions. If you are using a join with the column that is in the partition definition, then the partition engine will isolate that column and give you the join through the partition. So it will not go through a full table scan, but it will be only the partition that is involved in the join. If not, it will be a full table scan every time. So shouldn't use it.
If you sometimes you have to just look up values from another small table, and if you would replicate this small table on the servers, data servers, it would be impossible to join on the data servers, I think. Or joins are executed on the first 1 and 8 here.
Do you know what the federated engine is? Okay, federated engine is the same thing, but one-to-one instead of one-to-many.
Many pitfalls.
Yeah, many pitfalls. But the federated engine is something that you can use if you know how it breaks, and you can break in many different ways. For instance, one thing that I do when I use the federated, it's connecting the federated table to a view instead of a table. So in the view, I have the join with a small table in the mod server. So the query is very inexpensive because the join is done remotely, is very quick. I get the answer back. You can do that with Spider as well, but you need to be very creative.
How automated is it though? Because in doing all that using federated, it's good that you have the control, but the whole
It's
point
not
of
using federated.
right. I'm saying as opposed to federated.
It's,
If you were using federated, you have to make views, you have to do all the work, right? Just like if you sharding the application, you have to do all the work, right? So I'm asking how automated is Spider? Do you do some of the work, none of the work?
it does everything inside, but not everything is optimized. So you have to know that if you, depending on the query that you do, you may end up with a long waiting time. And you can see immediately, if you do a select star from this table, it's not going to be quick, because it will ask all the servers for the records, and then it gives you the answer.
So they star group by something, but not
So, actually, even a select count star is going to be very slow.
I've got a question also about replication. Is it possible to replicate, even row-based, using the Spider engine, because you've got all the engines?
We are not talking about replication here.
I know, but I'm asking.
You can replicate this.
Even the Spider engine?
You have to replicate the back posts.
Yeah.
You don't replicate this one, it doesn't make sense.
If
you replicate the spider table, you may break replication. It's the same problem that you have with federated tables.
Okay.
Because if you have this replicated, so you see, you have two tables in two different hosts. This is the master, this is the slave. They both point there. If you do an insert here and it's replicated, you do an insert here, you break replication.
Of them, yeah.
So you cannot replicate a spider table.
But
you
if
have
I
to
switch,
explicitly remove from a replication, otherwise you break replication. It's the same problem that you have with federation. cannot go around it in MySQL replication schema. Yes,
No, that was.
that was okay. Oh, let's get our hands dirty. Yes.
One of the scenarios you said in the beginning was choking the master on write. So how does the spider help here?
Oh, because you don't have one single server. You have 8 servers. So you choke this when you feed all the servers in the backend.
This example you see years, a lot of the writing tends to be like whole year 2009 because this is the year.
Okay, just an example. Depends on how you shard it. If you shard by user ID, so as long as you have backends, you don't choke. And actually, you can scale it. So if you need more space, you add more backends. You cannot choke this because you have the possibility of expanding. If you have a single server, once you finish the space, once you have finished adding disks, memory, everything, it chokes. If you can add more masters in the backend, then it continues. This is the difference.
So the spider
It's not one.
because in this situation you have two MySQL servers with spider. I cannot write to both of them.
That was a special case. Only this. You have one master, one spider engine, spider table, and many backends. So this is zero data. It's just a fake table.
Yeah, I understand. So the MySQL server for the spider engine can have a lot higher write load before he chokes. But at some point, just the overhead, what he's doing, and he can choke also at some point. What do you do then?
It will reach the point of choking much later than a single server.
Yes.
Because you can expand this. So if you need, you can have up to 1024 backends. Once you are there, then you have to think something better.
That's my question. What is the next better thing then?
I don't have an answer for this.
Okay.
Probably we can extend the partition protocol to accept more than 1034 partitions, but at the moment this is the limitation.
But spiders be nested?
Hmm?
Can you nest spider?
I haven't tried that. You can nest it. Possibly, yes. Why not?
I'm just thinking of, I mean, nevertheless, the host 1 here still needs to deal with all the client connections coming to him to drop off the write loads.
You know, anyway, this is a
still
partitions
Some
problem. Because okay, if you are dealing with Facebook, then you have to add new hosts. If you are dealing with a historical database, you do something like that. You have a partition by month for the recent records, a partition by year for the records from 2000 to 2008, and you have a partition by every 10 years for all the records. So one partition will give you more data. It depends on how often you question the data, but this is a technique that will keep us talking too much. Let's go to the practicalities. Installation. So if you want to use this, you have to install it. At the moment, what you have to do, you have to get your hands dirty with source code. There is a spider engine already compiled for Linux AMD 64, but to use the spider engine effectively, you have also to apply a patch to the server. So let's decide how to do this with the source code. So you need MySQL source code. 5137 is the latest one that you can get. get the source code of Spider from the launchpad and get the source code for the patch for condition pushdown. So you have to unpack the MySQL source code, unpack the Spider source code and documentation. Documentation is written in Japanese English, meaning that it is once you have done this twice, you understand what he's talking about. But it's kind of cultural shock to read it for the first time.
It's like when you go to IKEA and you get furniture and you put it together.
Yeah.
The instructions that you don't understand what you're saying.
Something like that. Or when you have lunch with an Italian, it looks like he's speaking English, but sometimes it's not that. So you have to unpack the source code, the Spider source code, and the condition pushdown patch. Now, I can read your mind. What the hell is a condition pushdown? This is a Spider-Man, sort of, in ASCII art. If you can read, if you are far enough to see. So what is pushdown? Think about this. When you automate a client-server protocol like federated tables or Spider, you have to take the queries that come from the client and send these queries to remote servers. And you have to change these queries. You cannot send the query the way it is. So the current simple algorithm that is used by the federated engine and also by the Spider engine first version was something like that. You select start from somewhere with one where clause, and the where clause were somehow lost in translation. So the condition was not push down the query down the remote server. So the remote server didn't get the condition, meaning that the server will return too many rows, and this was inefficient. This is a problem with federated. If you apply condition push down, then you can get the condition in the remote server, meaning that the remote server works less and gives you the right amount of data. So if you test the Spider engine without the condition push down patch, it is still faster than a whole big table, but it's not as fast as it should. If you apply the condition push down, it becomes 10 times faster. So this is what you have to do. So let's go on. Installation. Once you have unpacked everything, you move the Spider directory down to the MySQL source code tree. Then you apply the patches. Don't worry trying to copy everything, you will get the slides eventually. Use the patch command to apply the patches, and this works. Then run the installation. Now, quickly, on the last row, Marcus and Beat, you can read this and repeat backwards. Okay, never mind. No, you can copy this from the documentation, and it works. Finally, you create a binary tuple, and now you are ready to use the Spider engine. So now you can read the manual and install manually the Spider engine, or you can use MySQL Sandbox to do this with one simple command. If you want to know more about MySQL Sandbox, at 5:45 in the main session of FrOSCon, I have a presentation about that. So just trust me that it works now. This command here will create one, will install the Spider engine and will give you something ready to use. We are not done yet. Once we have installed, we have set up the engine. So the engine doesn't work fine if you don't prepare some tables that it uses internally to keep track of what it's doing. So I need some tables to record what tables were created and to which servers they are related. So again, look at the docs. The documentation, you can see the SQL code that you have to eventually paste to the command line, or you can just take this one that is taken from the documentation but is nicer and easier to use. So you just run this through the Spider engine, and eventually you will have in the list of engines Spider, a plugin, together with the other engines that were created with the installation. So we have done conceptual things, the installation and the setup. If you have followed so far and you have not fallen asleep, we are ready to use Spider. And we start with a simple case. Now, don't be scared because the simple case doesn't look simple at all. But, you know, we are talking about one table that looks like a table, but it has some remote servers, so it has to be complicated somehow. It cannot be more simple. So first of all, using again MySQL Sandbox, we created 3 servers. So use this command, make multiple sandbox. You can create 3 servers with port 6001, 6002, and 6003. And you don't have to use Spider in this server. This is normal MySQL server. Again, using the sandbox, you can ask these new servers to tell you their port, and they tell you 6001, 6002, 6003. Why is this important? Because this is a test. So using a single environment, we are pretending to be remote servers. In this case, all the IPs will be 127.0.0.1, so will be the same host, but theoretically, actually in practice, it works the same as if you have remote servers. So just to be clear, we have one main server that contains the Spider engine and is using port 5137, and we have 3, let's call it remote servers in the same laptop that use port 6001, 6002, and 6003. Now let's see what we do. In the remote servers, we create a simple table. Table A with 2 columns. No particular things. Just a simple table with 2 columns. Okay, these are the tables in each server that will contain the data. 10 minutes left. Yes. 12 actually. So you run the the script to the remote servers and we restore this table. Now, in the main server, you have something different. You have the same table description with 2 columns, but engine equals spider, and it's not finished yet. This says continuous. What is the difference? First of all, we have a connection clause. It's the same thing that we do with federated. And in this connection, we tell the spider engine that is it has to look for a table A and using user and sandbox with password and sandbox. Again, we have something more. We create partitions, and I cannot tell you how to do the partition because this is another presentation that will take long. But if you know partitions, you know that this is standard partition description. Partition by range, column A, partition, name of partition, and values less than 1000 is standard to understand. The comment is something that is different. In the comment, you say that the host is 127.0.0.1 and port 6001. This is why I was insisting on these ports. And the same happens for partition 2, connects to port 6002, partition 3 to port 6003. So we have one definition of a table with additional code to tell the spider engine where to get the data or where to put the data. So we feed this code into the main server, and finally we are using this. We insert into table B values 500, 1,502, 5,003. And it says that it has inserted 3 rows. If we query this, we just get the result. But what is the data? The data is split into 3 hosts. 500 is in host 1, 1,500 is in host 2, and 5,000 is in host 3. We can again ask MySQL sandbox to tell us where the data is. So he asks all the remote hosts with the query select star from MySQL table B, table A, and it gives you the answer. 500 you can find in server 1, 1,500 in server 2, and 5,000 in server 3. Roger so far? You are confused, enlightened, bored, dead? No, because you know, now we have the complex one. So that one is the easy part. This is the one that we take from the documentation, and again, if you translate very well, you can get it. So you can use more remote servers to do something better with the employee test database, which is a database containing something like 4 million records. So let's draw the table and then make, instead of 3 servers, we make 20 backend servers. For these servers, we use the remote employees database. Now, I'm not going to show you all the source code. You can get the source code from the net. The only thing that I'm telling you is that these 2 tables, titles and salaries, are the biggest ones. They have 700,000 and 2,500, 2,500,000 records, and these ones are the ones that are split across servers. The Spider engine is using the backend server for these two tables. In the main server, we just load the employee database using the small tables locally and the two big tables using the Spider. In using MySQL Sandbox again, we can see where the records are. Now we cannot see all the 20 servers, but you can see there are 18,000 in server 2, 37,000 in server 3, 57,000 in server 4, and so on.
Is it coincidental that this number is increasing?
No, it's just they stabilize. Because these are historical data, so there are not so many old records. So we can have a quick demo, very quick. Where everything can go wrong. Okay, this already started.
Can you make the font bigger? No.
Okay. Okay, this is the description of the table, where you can see that we have all the things that we had in the simple case, plus many more partitions. So we have 19 partitions here instead of 3. Select, count, star from salaries, where from date between 1999 0401 and 1999 05 02. In 0.41 seconds, I get 22,918. Now, at the same time, I have one installation of this database. was here. Let's copy the same query and give it to the place where we have the full database. Okay, so it takes 3 seconds.
In what planet is it 3 seconds?
This is the full database in one table, but the numbers are different.
That's weird.
Probably they found out that. No, it's a different query, sorry. Okay, so the numbers are the same. It went wrong, but not so dramatically wrong. So it's 2 seconds against 0.41 seconds. So in this case, we have the Spider engine that is sending the query to a remote server. The remote server now is all 20 servers are inside this small laptop. So it's something significantly, let's say, there is some overhead for that. But despite the overhead, is much faster because there is a partition and there is a server that is doing only one portion of the work. Now, the demo could be much longer than this, but we have finished the time. So, this is the end of the presentation, and you can read more in my blog. There are a few articles about Spider, and you can read the home of the Spider engine to get more source code, and you can look at the slides in SlideShare data share. They are not there yet, but they will be there in a few hours. So, query and answers eventually. So you asked a couple of questions. What is your size? L. L. Thank you. And what is your size?
Mine?
Yeah.
XL. XXL.
Oh, it's my size.
L and then exchange it later.
XXL.
XL.
The largest you got.
You will get an Excel later. Don't wait, it's Colin's phone.
Very not spicy.
They're all L.
The black ones are big. Use the black ones. The black
The black L's are big.
This is big.
Thank you.
Questions? Yes.
Not sure if you mentioned it, but the partitioning algorithm is the ones used by the MySQL practitioners or kind of their own partitioning?
No. It's the partition engine from MySQL. If you, yes.
What are the main benefits over partition table? To build a partition and storage engine, did you say what are the plus features?
It's faster than using normal tables, but it's a completely different presentation, and as I said before, I can talk for hours about that.
No, I thought the Spider engine is based on the partition engine.
Because it can have remote partitions instead of
Distributed.
local ones.
You can spread them
So
all
in
across the
normal partition, you can spread things across the server, but it's in one server. In using the Spider, you can spread them across several servers. Whoa, okay.
When you have your test, you didn't have an index on date, right? So this is basically a full table scan in our case, and that's using a partitioning function, right? So what if we will add an index on the date? It will be this index, right?
It would use the
Yeah,
index.
did a test with the index?
Usually partitions are more efficient than index. So you use partitions where you have too much data,
To
when
scan,
you
right?
don't have enough RAM to fit the index inside. In that case, partitions is far better than the indexes.
And the Spider engine can scan can perform a parallel reads from the different server. Can it? No? Okay.
It's not parallel.
Okay.
Unless something, I miss something in the documentation and I don't understand that.
Okay.
It could happen. But if it does, I will put it in my blog. More question? Yes.
What's the main advantage towards MySQL cluster?
Completely different story. Now the expert of MySQL cluster is that guy standing there, and he can tell you that it's apple to oranges. So if you have a scaling problem, sometimes you can take the cluster and solve it, but it's not a drop-in replacement. Most of the cases, it's not. Cluster can solve when the problem is right. Cluster is a wonderful solution, but most of the cases is not.
Spider doesn't give you high availability, for example. If one of the shards is down, that piece of data is missing. While cluster, every node has
And
a
it's okay for you?
Oh, medium would be
Medium.
nice.
Medium.
Here, I've got a pen, we can just write M on it. They all have M's, they all say MySQL.
That's
they all
actually
have
the
M's.
Okay, thank you very much.
Okay, a last question about transactions, especially you said about two hosts doing the, I say, master thing and the backend. Is there some XA transaction
Yes.
management?
Yes, if the remote host support transactions, the Spider engine tries to use it. So the Spider engine tries to send a transaction to the remote host to do as much transaction as is possible. So it's using an XA protocol for that.
So will it roll back?
I don't guarantee that it works, but it's trying. So let's, now we have a...
Yes, we now have a short
And
break.
that was the end. Thank you.